Good morning, 7th grade. So this video is going to review parallel lines that are split by a transversal. And a transversal is this line right here that intersects two parallel lines. So when you've got two lines that never, ever, ever touch, like right here, line N and line M, and you have a line that intersects them going the same angle all the way through, that's called the transversal. And that's going to be a line that intersects two parallel lines. So we can use what we know about angle relationships and apply it to this picture. So we can use what we know about parallel lines as well as vocabulary to help us determine relationships between certain angle measures. So here it says name and highlight the corresponding angles. Well, corresponding angles are going to be in the same position on both of the parallel lines. So what that means is if I start out, let's start out here with angle 1. If I'm looking for the angle that's going to be in the same position as angle 1, I'm going to look to line N and I see that angle 5 would be in the exact same position if I just slid it down the transversal. If I took angle 1 and slid it down the transversal, that would pair up with angle 5. So one set of my corresponding angles are going to be angle 1 and angle 5. That's one set. So I want you to try and identify the other three sets. I'm going to pause right now. Hopefully you were able to see that angles 2 and 6, 3 and 7, and 4 and 8 are also going to be corresponding in the same position. And corresponding angles are congruent, which means they are the same. So what I can do is I can say angle 1 would be equal to angle 5, angle 2 would be equal to angle 6, angle 3 would be equal to angle 7, and angle 4 would be equal to angle 8. So again, corresponding angles are going to be in the same position, which means they're going to be equal to each other. Moving on to a different set of vocabulary terms, we have alternate interior and alternate exterior. Well, let's use what we know. We know that alternate could mean going back and forth. In this case, alternate's going to mean opposite. So if we have alternate signs, positive, negative, alternate angles are going to be on opposite sides. So we see here it says alternate interior. Well, interior means that we're going to be inside the parallel lines, which means I'm going to be going inside the parallel line. So it says name and highlight alternate interior angles. So I want you to try to name the pairs of alternate interior angles. Alrighty, hopefully you could see that 3 and 6 are alternate. They're on opposite sides of that transversal, and they are inside the parallel line, so they are alternate interior angles. The same thing would go for 5 and 4, again, being on opposite sides of the transversal. So alternate interior angles are congruent, which means that angle 3 equals angle 6 and angle 4 equals angle 5. So if angle 3 was 30 degrees, that would make angle 6 also 30 degrees. Using that knowledge of alternate interior angles, try this one over here. Name and highlight the alternate exterior angles. So I'm going to show my answers in 3, 2, 1. Hopefully you were able to see that angle 1 and angle 8 are alternate exterior. They are on opposite sides of the transversal, and exterior means the outside of the parallel lines. And as well as angle 2 and angle 7, again, opposite sides of the transversal and at the outside of the parallel lines. So again, alternate, opposite, interior meaning inside, exterior meaning outside. So instead of being alternate, let's deal with same side. So same side is going to refer to the same side of the transversal, again with interior meaning inside and exterior meaning outside. So I want you to go ahead and I want you to try to see if you can name the same side interior angle. So again, interior means we are focusing on the inside of the parallel lines. Were you able to see that angle 3 and angle 5 are on the same side of that transversal, but inside the parallel lines? Awesome. So you were able to see that we've got two pairs that are on the same side on the inside of the parallel lines. And these angles are supplementary, which means that they add up to 180 degrees. So angle 3 plus angle 5 is 180. Angle 4 plus angle 6 is 180. Because if I would move 6 to be next to angle 4 or 3 to be next to 5, vice versa, I would make a straight line because, again, we can just slide it up and down the transversal. So I'd like you to try this one on the other side of naming the same side exterior angles. Hopefully here you are able to see that 1 and 7 are on the same side of the transversal but outside of the parallel lines, as well as 2 and 8, same side of the transversal but outside the parallel lines, using those vocabulary words to help us determine the location. Same side, exterior. Alrighty, the last problem for this video is going to ask you to find the measure of all of the other 8 angles. Now, there are multiple ways that you could get this. First things first, though, I would always start off with labeling what you know. You can see here it says that measure of angle 1 is 120 degrees. So I'm going to go ahead and label what I know. Now, what I'm going to ask you to do is that you are going to use what you know about angle relationships to fill in what you know. So you could use what we just talked about in parallel lines. You could use what you already know about supplementary, vertical, adjacent, things like that. So I'm going to ask you to pause it and try yourself. So I'm going to ask you to pause it and try on your own. Alrighty, so this is how Miss Lieber worked through this problem. I saw that angle 1 and angle 2, when I combine them together, make a straight line. So since angle 1 plus angle 2 had to equal 180, angle 2 had to be 60 degrees. So that takes care of my first two. Then I took a look and I saw, well, 2 and 3 were vertical, so which means 3 also has to be equal to 60. Alrighty, that takes care of the angle 2 and angle 3. And I look at angle 4. Well, angle 4 is vertical to angle 1, so that takes care of angle 4. But oh no, then I run to 5, 6, 7, and 8. Well, I could just take all of these angles and then shift it down because, again, that transversal slices the same angle. Or I could use the fact that since 1 and 5 are corresponding, that's what allows me to transfer it all the way down. So angle 5 is going to match up to angle 1, 7 to 3, 8 to 4, and 6 to 2. It is important to note over here, and I may put it kind of in a little bubble, is that there are multiple ways to justify each relationship. For example, some of you might see the vertical angles right away. Some of you might problem solve and you might say, oh, well, 1 and 3 make a straight line, so I could have found 3 that way, or 1 and 8 are alternate exterior angles. So there are multiple ways to justify each relationship. So you don't just have to think in one direction. You can think in any way that your brain makes those connections between the terms, the relationships, and the measures. If you have any questions, please feel free to email me, as this will be featured on the last page of our problem set. And it's a great day to have a great day.